Hello everybody, this is Meghraj and I welcome you to my YouTube channel. Today we are going to solve the next numerical from chapter electricity. This question was asked in board exam for 5 marks. So this question has two parts. The first part is conceptual, whereas the second part is the numerical part. So let's read the first part. The first part is, will current flow more easily through a thin wire or a thick wire of the same material when connected to the same source? Why? So dear friends, here you should be knowing that the factors affecting resistance. So in textbook they have given the 3 factors affecting the resistance. The first one is the length. More the length, more will be the resistance. Okay. Then resistance is inversely proportional to area of cross section. That is, more the resistance, the less will be the area. Means if the area of cross section, is more, then the resistance will be less. And if the area of cross section is less, then the resistance will be more. So that is the concept here. So what is resistance? Resistance is just an opposition offered to the flow of current. So what does it mean? It means that finally the wire which is thicker, okay, through that the current will flow easily, and if the wire is thinner, then the current won't be flowing easily through that wire. Actually the concept of resistance is, suppose I apply a potential difference, that is the battery, across this conductor. Suppose this is a conductor. Then the electrons will start flowing, the free electrons will start flowing from negative terminal to positive terminal. Now while flowing, they come across other electrons, so they repel, and they also come across other atoms, that is nucleus, you can say. So nucleus has positive charge, whereas electrons have negative charge. So there is a very huge amount of, you can say, attraction as well as repulsion while flowing from negative to positive. So that is what makes the path of the flowing electron zigzag and not a straight line. So where there it loses energy, so that is the resistance. So if the wire is thinner, then the area to flow through the wire will be lesser, so the resistance will be more. Whereas if the area to flow, to overcome the barriers of nucleus and electrons will be more, then more amount of electrons can be flowing through this conductor, you can say that. Okay, so this is the concept behind the first part. Now let's go to the second part, that is the numerical. Some electric lamps connected to 220 volt of electric supply lines are rated 20 watt. Okay, how many lamps can be connected in parallel with each other across the 2 wires of 220 volt lines if maximum allowable current is 5 ampere? Now dear friends, listen to me very carefully. What they have given number of bulbs, some bulbs, you can say several bulbs or some amount of bulbs. So power of one bulb is given as 20 watt. Okay, then this bulb operates at 220 volt only. So we have connected number of bulbs in parallel. That's the condition in the question. We have connected some number of bulbs in parallel with a potential difference of 220 volts through the 2 wires. So this is a parallel connection, and you should be knowing that in parallel connection the current gets divided across each path. Voltage will be constant across each device in parallel, whereas the current will be getting distributed over each path. That is what I want to say. So we know that the voltage will be remaining the same. So the 220 volt will be there. Now what is the maximum allowable current is? Imax is 5 amperes. Now what do we know? We know this formula. P is equal to, that is power is equal to voltage, that is potential difference into current. So current across one bulb will be how much? Current is equal to power upon potential difference. So I just manipulated this formula right here and I just wrote the value, that is power of one bulb is 20 and it has to operate at 220 volt. So one bulb has to operate on this much amount of current, that is 1 upon 11 amperes. Now we have to find how many number of such bulbs can operate at maximum allowable current 5 ampere and 220 volt of supply. Now dear friends, after finding the current across one bulb, I will write current for one bulb into number of bulbs will be equal to maximum allowable current. So I across one bulb will be multiplied by the number of bulbs is equal to I max. So 1 upon 11 into n is equal to 5. So n will be 55 bulbs. So 55 bulbs can operate at the maximum allowable current of 5 ampere with the potential difference 220 volts. So that's all for today. Thank you very much for watching this video. I'll see you in the next video. Subscribe to my channel and hit the bell icon to never miss a video. Thank you very much.